All right, let's look at the homework 7.8, 7.9, problem number 11. All right, so we want to evaluate this double integral over the region bounded by y equals 0, y equals square root of x, and x equals 9. All right, so let's do that. All right, so first we're going to sketch the region. So here's the y-axis. Here's the x-axis. Alright, and the curves are, y equals 0 is the x-axis, and y equals square root of x, so it's going to look like this. Right, and x equals 9, so it's got to be somewhere around there, and this is that. Right, then we can just here is the region. Right, so let's set it up in two different ways. So the integral, double integral, right, same thing, y over 1 plus x squared with respect to, so let's do it, let's do it with respect to x first, and with respect to y next. Alright, so first we're going to fix y. So I'm going to fix y somewhere here. Right, and you can see that this is going to start from this curve and all the way to this x equals 9. So here this equation is either y equals square root of x, or you can rewrite it by square both sides, so x equals y squared. So this is going to start from x equals y squared to x equals 9. Right, and once you've done that, and let's see, I have to do something here, and here it's a square root of 9 is 3, so this value right here is 3. So in order to cover the entire region, you're going to start from x equals 0, then just keep on increasing, and you can see that all the way up to this point 3. So it goes from 0 to 3. So y goes from 0 to 3. Alright, so that's the first one. And the other one is going to be, so here is a double integral. Alright, same thing, y over 1 plus x squared. And this time we take the antiderivative with respect to y, and then with respect to x. Right? So we're going to fix x value. So it looks like it's going to start from y equals 0 to y equals square root of x. So we can write the y equals 0 to y equals square root of x. Alright, then after that we just have to swipe the whole thing starting from 0, and x is going from 0 all the way to 9. So x is going from 0 to 9. Alright, if we had a choice, I think I would go with the second double integral, because the first integration is pretty simple, because we just have to take the antiderivative of y. So I'll go with that. Alright, so first, since 1 over 1 plus x squared is just a constant, and just I'm going to place it in front of the inside integral. So you're going to have integral from 0 to 9, right? Then I put the 1 over 1 plus x squared outside. then antiderivative of y squared would be y would be y squared over 2. And then you're going from 0 to square root of x and dx. Alright? And then this is going to give us, alright, so plug in square root of x, so that's going to be x over 2 and minus 0. So I'm going to write x over 2. But over 2 is just a constant, so I'm going to put it in front. And 1 plus x squared. Then you have an integral from 0 to 9 and dx. Alright, then we can do a substitution on this guy. So I'm going to do a let u be 1 plus x squared. Then derivative of u with respect to x is 2x. And then take the reciprocal of both sides. So you have dx over du is equal to 1 over 2x. Then multiply by du gives us dx is equal to du over 2x. Right? So this is going to be, right, 1/2 is still there. Right? Integral. I forgot to do x is going from 0 to 9, which means that the u is going from, plug in 0, 1 plus 0 squared is 1, and 1 plus 9 squared would be 81 plus 8, so 82, right? So it's going to be 1 to 82, right? Then you have a u here, and the x is, I'm going to leave it, but the dx is du over 2x. So we can cancel, and x and x here, and 1 over 2, and place it outside. So it becomes 1 over 4. So I'm going to go up here. Right, it's 1 over 4. Integral from 1 to 82. Right, so of 1 over u du. Right, so this is going to be just a 1 over 4. Antiderivative of 1 over u is natural log of u, and you're going from 1 to 82. And this is going to be 1 over 4 natural log of 82 minus natural log of 1 is 0, so this is it. Alright, so let's type it in. Oh, actually, round to 3 decimal places. So let's open up a GeoGebra. Alright, so we got natural log of 82 and divide by 4. Right, so it came out to be 1.102. Right, so let's type it in. It came out to be 1.102. Right, so let's double check. Submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.